For just $1, you can actually buy anything, but not a real 3D printer, of course.
No, seriously, what were you expecting? $1 3D printer?
Still, today we managed to find both printer-like alternatives and real 3D printers for $1, $10, $50, $100, $200 and even $1,000. We'll put each of them through different challenges to figure out what the real differences are and whether paying more is actually worth it. And we'll also print a 3D printer and a 3D printer. Let's go! For $1, all we got was a pile of parts that, once put together, turns into the cheapest 3D printer in the world.
Are you kidding me? The just a lighter was it you?
This is the cheapest 3D printer in the world.
Because once we take a piece of suitable plastic, our device actually prints with it, or at least pretends to. And since a 3D printer is technically a device that creates physical three-dimensional objects by adding material layer by layer, our contraption can technically qualify.
Are you seriously planning to use this for testing?
Every 3D printer, or whatever counts as one, will go through 8 different challenges today, earning a score from 1 to 10 for each.
But in the case of this, some tests just won't be passed at all. So let's just take it one step at a time.
The first challenge is packaging and accessories, and since our Frankenstein setup has neither, that's an unfortunate 0 out of 10. Next up, ease of assembly. To put this device together, you only need 2 hands and about 3 minutes. So this one gets a solid 9.
The quality of the product, as we've already noticed, is really poor. After just a couple of uses, the printer melted and no longer works.
Which means for category number 3, printer quality, the absolute maximum is 1. The most important parameter of any printer is print quality, and here I don't really have much to say, just because calling this quality would be a stretch.
That's how I love my subscribers.
Technically it works, but let's be honest, this isn't something you can take seriously.
Okay, just for the fact it's even possible, let's give it 1 point.
Print time was supposed to be measured using a pre-prepared model, and capabilities by how much you can actually print. But since all we managed to make was a tiny rocket, a staff, and this little heart, I think there are no questions here.
And now we have features. Well, 1 out of 10 for originality and overall impressions.
Even for its price, calling this device useful would be a stretch, but purely for fun, it works. Let's see what you get with the next one. Now for the $10. For a price 10 times higher, we still don't get a real 3D printer, because this is just a 3D pen.
On the other hand, we already get a complete product that might even work properly.
At the very least, we finally have packaging and accessories, and the bundle is actually pretty generous. Inside what looks like a small box, there's a whole bunch of extras.
In addition to a pen, the kit includes 3 different colors of plastic, a manual, a stand, a power supply, a cleaning tool, a printing plate, and a full set of 10 stencils.
Which means the score here has to be high. To start using the pen, all you need to do is feed a piece of 3D filament inside and plug the pen into power.
Here's a bad filament, because I hear some cracking sounds and it can't move on to the pen.
The only issue was that the filament included in the box turned out to be awful, so we had to swap it for our own, and that's basically everything we had to do to make it print.
You'll soon understand why this parameter is so important. Because it's a classic story with larger ones, when setup and assembly of 3D printer is actually more complicated than using them.
The technical specs of the pen claim a lot of things, but let's be honest, we can't really trust that. So we'll test every parameter ourselves, starting with build quality. The pen really can heat up to 230 degrees, the temperature is shown on a small screen and adjusted with buttons right next to it. Feed speed is controlled by a slider on the side, which is actually very convenient too. And all of this really makes the pen work. And honestly, I was surprised, but it works well. The pen prints way better than I expected from a $10 device.
It's a rocket. The only thing is, I'd like a slightly longer cable. It's not very convenient to work with it as it is.
Which means for build quality, it gets a 7 out of 10. Now we move on to the most important part, print quality.
This category will have 3 challenges, and for each one it will gain points.
And here, obviously, the pen can't be compared to a real 3D printer in any way. Sure, a lot depends on how steady your hands are, but even a simple 3D cube is already an impossible task for a pen. I mean, technically, you can make a cube by drawing it unfolded and gluing the sides together, but to put it mildly, it looks nothing like the original model.
Moreover, inside it's empty, so it's kind of a cheat. So only 2 out of 10.
So yeah, the pen isn't making it to the rest of the test. Next, we were supposed to test print speed using a model of this cup. But do I even need to say that perfectly reproducing the model is impossible? Which means we can't objectively measure speed either.
Therefore, in essence, it should really be a 0, since like the previous case, the model just doesn't match up. But for real speed and effort, we can edit 1 point. How do you think? Can we drink from this cup? Yes.
The biggest and most interesting category is capabilities or printing versatility. This is where we talk about size, materials and use cases. Basically everything that answers the question, what can you even print with this thing? For example, the print area of a pen is technically unlimited. Grab a bigger sheet and you can make as large parts as you want.
Another question, of course, is how practical is it for use?
Unlike the previous pseudo printer, here we can already print somewhat recognizable objects and easily switch filament colors. But the material will almost always be the same. PLA is the lowest temperature and simplest plastic. Downsides, low heat resistance and relatively low strength. And as for the upsides, there are way more. By the way, the box boldly claims that you can print TPU and ABS. We'll talk about TPU a bit later, but ABS is technically doable. ABS plastic is stronger and much more heat resistant than PLA, but also much harder to print. And the pen does heat up to the required temperatures, but the filament flow is very weak.
Additional ABS plastic is very toxic, so it fumes, should not be inhaled while melting, and it should only be used in enclosed printers.
So I hope you get the idea. It's possible, but definitely not recommended. TPU is a flexible rubber-like one, and since it has a lot of nuances, now I'll just say that printing with it is also possible. So what do we get? Unlimited size, materials, colors, stencils. On one hand, that gives us tons of printing options.
But on the other hand, all these models are not practical and have no real aesthetic use.
And realistically, everything this pen prints is only useful for the printing process itself. Is it interesting? Yes. But do you actually need any of the printed results in real life? Yeah, I highly doubt it. 2 out of 10. As for features, I can point out the pen's extremely compact size and low power consumption.
So it turns out you can print almost anywhere, almost nothing useful.
Alright, let's throw in a couple extra points. In the end, even though you can't really call this pen a 3D printer, for its price it delivers a lot of positive emotions. But of course it doesn't even come close to a real 3D printer, which means it's time to move on. Only at $50 did we finally manage to find a real, even if very small, 3D printer. This one is made by a brand called EasyThread, and honestly, I've never dealt with printers this cheap before.
And on top of that, we got it for the very good price. Sometimes it costs even more.
The packaging. Let's be honest, doesn't even deserve a 3 out of 10. But at least we have a mini spool of filament, a screwdriver, a flash drive, and for some reason, 2 USB adapters in the box. Everything else is just the printer in pieces. According to the manufacturer, this printer is very easy to assemble, but...
Okay, firstly, it's all in Chinese.
Flip it.
Alright, but honestly, it really is that simple, even with a ridiculous manual that looks like one of the very first websites ever made, and the manufacturer's obsessive urge to show me some video.
Watch printer video. Watch Kura set video. Watch video another time. Where's the video to watch it? Give me the QR or a link.
Text them on WhatsApp.
The printer comes together surprisingly easily, literally in just a couple of moves, without a single screw. I'll be completely honest, even a kid could handle it.
And we've done it for 10 minutes and even without a screwdriver. But that is far from the end, as now we have software configuration and calibration ahead.
Once powered on, absolutely any 3D printer requires calibration. And here the process is fairly simple. You take a regular sheet of paper and adjust the distance between the nozzle and the bed until it slides with slight resistance. You repeat this in 4 different corners, and only after that do you load the filament into the extruder and feed it until it starts coming out evenly.
Oh shit.
For ease of assembly and setup, 7 out of 10.
Remember what I said about quick assembly? Well, that played its part in printer's quality.
Because the printer is very small, very light and barely held together, the entire frame flexes a lot.
I'm not even mentioning the travel of the print bed. I'm not mentioning that it's quite crooked on its own, but when it comes to the move of the X-axis beam, it's impossible to ignore.
During movement, the gantry literally shifts by several millimeters. And how exactly are we supposed to talk about calibration when the nozzle height constantly changes?
And also for some reason from time to time it likes to do that.
But surprisingly, none of this stops it from printing. We were able to start the very first simplest test model. And honestly, it printed it not terribly, even though it took almost a full hour. So yeah, here are the technical specs, but as we already know, they don't say much here either. Build quality gets exactly what it deserves. Now let's move on to print quality.
And to begin with, let's get rid of the weakest link, this 3D plastic.
Printing with the filament included in the box wouldn't be fair. It's much cheaper and much worse. And the colors for the 3 test are different anyway.
But now it's unclear how to attach it here.
I also have no idea where to find such a tiny spool. We even considered making our own mini spools and rewinding filaments somehow. But the cameraman came up with a different solution. The setup works. So let's move on to the first of 3 print quality tests, the cube. We download the model, open the slicer and convert the 3D object into printer code. All that's left is to insert the flash drive with the G-code into the printer, start the print and realize that the cameraman's idea didn't actually work. The printer is simply too light to rotate even this spool, so we just unwind a few loops of filament by hand, it'll be enough anyway. And finally, the first quality test, the cube. A bit crooked, a bit wavy, but at least it counts. I'm giving it 2 out of 3 points. We swap the filament for yellow and start the complex quality test, the second of 3. For this one, the printer had to run all night, it struggled that much. But in the end, something did come out.
Look, this little bolt printed out in such a tiny scale. This in, even this little spiral printed. And even all bridges. Yeah, they got a bit layered, but they did print.
Okay, let's be honest, this is bad. Very bad by the standards of any normal 3D printer. But for our tiny one, it's actually even better than I expected.
And of course, for the most part, it pretty much failed every one of these tests. But in its case, it's already an achievement that it printed it all. So I think we can partially count that.
1 out of 3 points. That leaves the last and hardest test.
I found this model with a description. This is a difficult torture test for your printer. Print at your own risk.
And here the printer failed completely. What we got was some kind of shapeless green blob.
Well, doesn't match, yeah?
No.
In total, for print quality, the printer scores 3 out of 10.
And we'll give it 1 more point for the effort.
Now it's time to talk about speed, which unfortunately is basically non-existent. I didn't mention this earlier on purpose, but this printer is so slow that our simplest cup took a full 4 hours to print.
And finally, from this one we can drink. Or maybe not.
Well, one layer split, you know how it goes. For print speed, a maximum of 2 out of 10. Next up, printing capabilities, and here it's a failure in almost every subcategory. Let's start with size. This is the smallest 3D printer I've ever seen. The build volume is just 10 by 10 by 10 centimeters, which means you can print objects roughly the size of a Rubik's Cube.
Plus, right out of the box, the table surface has some unevenness, which knocks off another couple of centimeters.
Now materials. Because there's no heated bed, all we can realistically use is PLA. You could try TPU, but considering all the printer's downsides, that won't be easy. We managed to destroy the build plate in a single attempt and had to come up with a replacement. Ours, by the way, turned out even better than the original. So in the end, this printer can only make something very simple, very small, and very limited in use. And we did manage to find a few examples. A small keychain, a little boat, cones for a minicar, and even a game. Finding anything even slightly functional was especially hard, but we managed to make a mini tic-tac-toe game.
Yes!
It also did break almost immediately, but that doesn't matter. So for printing capabilities, 3 out of 10. As for features, I want to point out USB-C power support. Combined with the size, that means you can technically print anywhere. Plug it into a power bank and print in a garage or even outside. The main challenge is not falling asleep while it slowly pushes something out.
That's supposed to be a bolt and a nut.
And always being ready for a completely unpredictable result. In the end, a $50 printer is still not a fully fledged device.
And to say that it covers any real needs, of course not. This printer isn't for printing that you need. This printer is for printing that it can. And it is really more for learning, because if you learn how to print on this, you'll definitely handle something more expensive.
So overall, let's give it a 4, which brings the final score to just 30 points. For $100, unfortunately, we still can't buy a proper FDM 3D printer.
What does FDM means, I'll tell you in a minute. And now?
I want to show you something just as interesting. This is the Creality Helotor 6, a resin 3D printer that works using a completely different technology. On our table is the cheapest resin printer of them all, and for $100, besides a nice looking printer, you don't really get much else. There isn't even any resin in the box to try printing something.
No, seriously, nothing more.
So for packaging and accessories, just 3 points. But when it comes to ease of setup, everything here is perfect. To start printing, all you need to do is plug the printer into the outlet and press one button.
Wow, that's so quiet. Wait, where do you insert the filament? Where's the nozzle? How does it even work?
And while the cameraman is trying to figure out what's even happening, for ease of setup, this printer gets a full 10 out of 10. And now let's get to the most important part. When most people hear 3D printer, they usually mean an FDM printer, one that melts plastic and lays it down layer by layer. Resin printers work very differently. They use ultraviolet light to cure liquid resin poured into a vat. And honestly, I didn't even know printers like this existed before. And everything about this printer is different. The build plate is upside down, instead of a nozzle and extruder, there's a vat and a screen, and even the slicing software is completely different. And instead of solid filament, you pour liquid resin into the vat, which, by the way, is very toxic, and you really don't want to touch it with your fingers.
And also it is 2-3 times more expensive.
The printer itself, however, is very well made and looks much more expensive than it actually is. A color touch screen, enclosed body, great build quality. On top of that, you can even send print files over Wi-Fi, although it works pretty poorly.
Oh,
time to see it in action. We prepare the model, pour the resin inside, and leave the printer to do its thing. And then, 3 hours later, the printer lifts an empty build plate. Okay, that's weird, for some reason nothing printed. But there is a small piece of board stuck to the bottom of the vat. Alright, let's try recalibrating the build plate and run it again. Second attempt.
And the same layer again.
And exactly the same result. We cleaned the printer, swapped the resin, and even followed advice from ChatGPT by lightly sanding the build plate with fine sandpaper. But honestly, something still wasn't right, and time after time, same story again. I would have probably lost my mind if my friend Vlad hadn't come in and explained that we were slicing the model incorrectly. Turns out that was the issue. And finally, on the 4th attempt, the printer made our little boat. So the hardware itself is pretty solid, but the software is very strange. Why it refused to print without manually added supports, I honestly don't understand. But if you think the printing process ends here, not even close. After printing, the model has to be washed in isopropyl alcohol. And the smell is so strong that working without a respirator is almost impossible. And after that, you still need to cure the outer layers with ultraviolet light. There are even special machines sold just for these 2 steps, but we managed with our hands and a manicure UV lamp. And besides all of that, resin printing has one more feature,
Which have a big difference with other 2D printed models. And which difference, I think you've already guessed.
probably the most important one. Print quality. Here, on resin printers, it is usually much higher than on their FDM competitors. Since we only had one resin color, we decided to print everything at once and show you the results across 3 tests. No point dragging these out. When it comes to detail, it's almost perfect. The cube is a clear 3 out of 3. The complex test, even though it needs a bit of post-processing, also turned out great. Just look at how detailed even the smallest elements are.
I'm not sure whether to count it for quality or not, but it's very fragile, and we can see it.
Another 3 out of 3. And unlike the previous printer, it passed the 3rd test as well. The tiny pass-through fidget came out fully functional.
And honestly, I don't think any FDM through the printer will achieve the same level of detail as resin printer.
I'll only deduct 1 point for fragility, but all in all, print quality gets a solid 9 out of 10. But speed? That's where things get much worse. Printing our cup model took a full 6 hours.
And that's very long. It's even 1.5 times longer than the cheapest 3D printer.
And on top of that, you still have to spend time on post-processing. At best, another 15 minutes.
And that's so messy, so dirty, such a lot of trash of it. And the biggest problem is how bad it smells. Oh, well, it's not the best idea to do this in the flat, and I'd like to give it even less.
Alright, so just 1 point for print speed.
And moreover, I still cannot drink from it.
But why?
Because it's toxic.
Let me smell.
So what do we have in the end? A small build volume, very limited materials, extreme slowness, complex post-processing, toxicity, but incredible detail. So what do you print on a machine like this? The answer is simple: figurines. Where regular 3D printers will always leave visible layers, a resin printer makes models extremely detailed and, most importantly, smooth. Although to make them actually look good, you still need to paint them. Anything else? Not really. Because of all the downsides, people usually don't print anything else on these machines. This is a very narrow, specialized tool for a specific task. That said, resin printing time-lapses look amazing. The printer literally pulls objects out of thin air. So, overall, it's hard to give printing capabilities a high score. Features.
As for the features, I can mark how silent it is, but it's so toxic and smells so bad that sitting in the same room with it is impossible, and that just cancels everything out.
Well, let's give it 3 points. And for overall impressions, I'll give it a 5.
Now I'll explain why.
There's a huge difference between pulling out a finished printed part and then spending another half an hour processing it. Processing it while breathing alcohol fumes and accidentally dripping resin everywhere. In the end, this kind of printer is really only for people who already understand what they're getting into. But thanks to its strengths, it still scores a total of 41 points, which puts it in the lead. Let's see if the next printer can change the situation. This one is already twice as expensive. For $200 we bought the Creality Ender 3.
And to my mind, it will be a little bit difficult to assemble it due to its size.
Let's not beat around the bush and jump straight into the unboxing. Inside the box there's a neatly packed pile of parts and accessories that almost takes over the entire table.
Oh, and also 2 binders here.
Along with the printer itself, we found a micro spool of filament, cutters, a nozzle cleaning needle, a scraper, zip ties, a spare nozzle, a USB adapter, a flash drive, and some tools. The bundle is really good, but something tells me this won't be easy to put together. To speed things up, we decided to assemble it together. But do you think it actually helps?
Now we need to unscrew that axis, then lock the motor to the profile and then to screw that axis.
Well, let me spare you a few minutes of my frustration. The assembly itself isn't nearly as hard as the instructions are badly written. Until we turned on a third-party video, we spent half an hour struggling with the most basic steps. Still, overall, assembly here is much more complex than before. It took us almost 2 full hours.
And now it's time for software setup and calibration.
The calibration process is the same as usual. An A4 sheet of paper and about 10 minutes is all you need. After that you just feed the filament into the printer and set up the printer profile in the slicer. That's another 20 minutes or so. And here, if anything goes wrong during printing, every parameter has to be tuned manually. But we got lucky. The first print actually went well. 3 out of 10 for ease of assembly. Now about the printer itself, things aren't so straightforward here.
The first word that comes to mind, primitive.
Don't get me wrong, the printer is built pretty well. It's mostly metal, has a screen, a control knob and a solid heated build plate. But the bed is held down with binders, all the wires are exposed and the whole thing looks more like a factory machine than a finished consumer product.
And all of those, let's be honest, will not make it worse. For sure, it will work properly, but let's say it won't exactly fit in your interior.
Overall, it feels very custom built. That said, it prints really well. So, 6 points for build quality. Moving on. 1, 2, 3, the test models are ready and we can finally judge print quality. Unsurprisingly, the printer handled the cube with ease. There are some minor imperfections, but those are more about tuning than the printer itself. Same story with the complex test. It passed almost every part of it. There are a few flaws in small details, but overall, very solid. But when it came to the hardest test, unfortunately it failed. It looks much better now, but it's still not functional, which means only 1 out of 3 points. And a final score of 7. Now let's talk about print speed. No, I wouldn't call this printer fast, but compared to everything we've seen before, it's basically Usain Bolt. Just look at how obvious the difference is. Printing the test cup took about 100 minutes or roughly an hour and 40 minutes. And for the first time we actually got a proper usable cup.
And finally, I can drink from a cup. It was every single dollar from those 200.
7 points for speed. And finally, let's talk about what you can actually print with this thing.
In fact, it can almost anything, but just with some exceptions.
The build volume is 22 by 22 by 25 centimeters, and for most tasks that's more than enough. When it comes to materials, there's a lot more freedom here. Besides PLA, the printer even has a preset for ABS, which already says a lot.
But as I've already mentioned, ABS is very toxic material, and when it melts at high temperatures, it releases a lot of harmful substances.
To print ABS properly, you either need to build some kind of enclosure or print only in a ventilated enclosed space. ABS also takes much longer to print, and the smell in the storage room really was like burning plastic. Well, at least it's much stronger. Okay. Okay, next up is PTG. It's a slightly more heat-resistant alternative to PLA, but usually a bit trickier to print. There is no preset for it, but you can set temperatures manually. And finally, TPU. This is a rubber-like plastic, soft but incredibly durable. Its main feature is that it comes in many different hardness levels. The lower the number, the softer and more flexible the material.
In theory, you can print with TPU almost with every printer, but you should calibrate it well and enable a lot of different settings.
With stiffer TPU like 95A, the printer can handle it just fine, even though the print comes out a bit stringy. But for softer TPU like 80A, you need a direct drive extruder.
And it's a very difficult procedure, so we will try to print as it is.
And here, that just didn't work at all. The material fits unevenly. Sometimes it stretches, sometimes it jams. But as for variety, there are no real issues here. Most decorative, mechanical and even functional models are absolutely doable. Printing a simple bolt with proper threads or even a grenade-shaped model is not a problem at all. Whenever higher precision is needed, you just slow things down, and in the end, things actually work.
Oi!
Yes, speed can still be an issue. For example, printing a small basketball is not a quick task. For example, take a guess how long this time lapse is. 3 hours, 5, maybe 15. That little ball took a full 30 hours to print. But in the end, you could say it worked out.
No way!
Maybe we can glue it up.
Any large model can always be split into parts, so even something like this toy for my dog Pixel can be printed in a few runs. Look how simple it is and how much she liked it. Honestly, moments like this alone already make owning a 3D printer worth it. Using the Ender, we even managed to print a real toy cap gun. Not every part came out perfect, some had to be reprinted or retuned. PTG was especially tough for it. But in the end, we got a working complex mechanism inside a small object. So that's how it turns out. You can print almost anything, but for most projects you'll have to put in some effort. A solid 7 out of 10 for capabilities. Features.
And about features, they are unknown. And I also think we can name it a basic printer.
One important thing, if the power goes out during a print, the printer can resume right where it left off. 2 points for features, 7 for overall impressions, and a total score of 46 points. So for now the $200 printer takes the lead. Our video editor also wanted to tell you about his A1 Mini for $300, but I think everyone's way more interested in finally seeing the most expensive printer.
A bench.
And here it is, the $1,000 one.
In general, this printer is a little bit cheaper, but this is a combo version and we've paid for it a bit more.
Inside this massive box is the Bamboo P1S Combo, a printer bundled with a multi-color printing system. And it's so heavy that we decided to unpack it together. By the way, at the bottom of the box there are 3 full spools of different filaments. A small thing, but a nice bonus. Since the printer is fully enclosed, it looks nothing like the previous ones, basically just a big box. Inside there's a smaller box with accessories and that very AMS module for multicolor printing. All internal parts are secured with shipping screws, so nothing gets damaged in transit. And that's pretty much how it goes from here. First, we removed all the cardboard, plastic tape, protective covers and foam inserts.
That's like we're not assembling but disassembling the printer.
And only after stripping everything away can we finally see what's actually included. So, besides the printer itself and the AMS module, we get 3 200-gram spools of filament, spare PTFE tubes, a spare hot end, tools, a bunch of spare screws, a flash drive, grease and the thermal paste. And that seems to be it.
Well, to be honest, it's actually a bit lacking. For example, there are no spatula or cutters like in the previous printer.
But it turns out I was wrong. Here is a little message from the future. Apparently, the box also includes a scraper blade. But where's the handle?
On the SD card, cause you just bought a 3D printer.
Okay, that's a cool move. They saved plastic and also gave the user a bit of interaction. Print the scraper handle yourself. So, for packaging and accessories, a solid 8 out of 10. Ease of setup is one of the main advertised features here. The manufacturer promises you can start printing straight out of the box. All you need to do is mount the screen, connect a couple of tubes and cables and turn the printer on. After that, the printer connects to your phone and starts calibrating itself, seriously, on its own. No paper sheets anymore and, more importantly, no manual software tuning. Everything you need is already in the app, either on your computer or your phone. All that's left is to load a couple of filament spools. And by the way, it even pulls them in automatically.
And now it's ready to print. How much time did you do this? 15-20 minutes, yeah?
Like that, yeah.
So for ease of setup, 9 out of 10. The printer basically did all the work for us. The build quality will be judged while it prints this little pyramid. Alright, let's go.
My eyes can't even keep up with how fast it's moving around.
The body is high quality, but plastic, even though it looks like metal. The top lid and the door are made of thick glass. The door has a nice handle and it's magnetically held in place.
Oh, it's replacing the filament, look here.
The screen and controls are honestly pretty mediocre, which feels like a downside.
But from the other hand, why do you need to use the screen if you have all the same information on the screen of your phone?
Inside, the printer has internal lighting, a cooling fan and an air filter. But that's not the main thing. The key difference between this printer and cheaper ones is the mechanics. This type of printer is called Core XY. And if you haven't noticed yet, along the X-axis it's not the bed that moves, but the print head itself, riding on carbon rails. This design allows much higher speeds with almost no loss in quality. Meanwhile, the pyramid is done. In just 20 minutes, we got a model printed in 4 different colors. We'll talk about multicolor printing in more detail later. And for a build quality, a confident 9 out of 10. And since we have the AMS, why not print all quality tests in one go? We load the right filaments, combine the models and start the print. And wait, did I imagine that? Let's restart it again maybe.
Nope. Nope.
Okay, I won't drag this out. You can already see what's happening to the yellow test. We lowered the speed and tweaked the settings, but it kept doing the same thing over and over again.
Одно и то же раз за разом.
So it's clearly not on us. Let's rate the results. The cube came out perfectly, no complaints at all.
That was pretty obviously.
The yellow complex test also turned out great overall. All the small details, bridges, cones, everything printed better than anywhere else so far, and for the first time ever, even the barrels separate properly.
But why we couldn't manage to print these two little scenes on legs? I really don't understand. No matter how many times we tried, it failed one after another.
But the stamped cup didn't make it, so unfortunately only 2 out of 3 points there. The hardest test, this fidget tree, actually came out even better than on the resin printer. Yes, you can see the layers, but it moves way better. 3 out of 3, so in total, print quality gets 8 points. And if you're even a little attentive, you've probably already noticed the insane print speed. The cup model took just 35 minutes. And if we put it next to the cheapest printer in the same amount of time that we managed to print a cup the size of a bucket. If I could, I'd give even more than this, but officially 10 out of 10. Now we should talk about what the Bambula P1S can actually print, but this time we decided to do it a bit differently. Instead of theory, we tested it in practice. For over a week the printer ran non-stop, printing dozens of models, in different modes, with different materials and for different purposes. Some models were ready right after printing. Like this Ford Bronco. Look, it even has a suspension and spinning wheels. Others had to be assembled. In some cases, the fasteners are part of the model itself. In others, you need special threaded inserts and bolts. Look, these tiny threaded inserts are heat set into the plastic with a soldering iron, turning them into proper mounting points.
As a result, after more than 10 days, the whole table is full of examples. And also we've gained a lot of experience and can finally answer the question: so, what can you actually print with it?
The first thing that comes to mind is toys, puzzles and fidget gadgets. This printer has 3 major advantages here. First, multicolor. Second, enough precision for small mechanisms. And third, speed. Something like this can be ready in just an hour or two, and this model only takes 40 minutes. The same goes for all kinds of launchers, shooters, flyers, and basically anything that ends with Earth. No problems here. Thanks to the large build volume, you can print either big models or complex mechanisms. They are often split across many plates, but we almost always manage to fit everything. For example, here is a full safe with a working lock. Sure, it didn't print in one go, but much faster than expected. Or look at this fully functional gearbox. That one took several days and is extremely complex, but it's absolutely worth it. But my favorite model is this lock with a key and a full set of lockpicks. Simple, brilliant and completely realistic. Thanks to the enclosed chamber, the printer can easily handle ABS. And even more demanding materials, like PA6 nylon. It's incredibly strong, but requires high temperatures and ideal conditions. And about TPU. Finally, we can use rubber-like materials without pain. All it takes is printing a small direct drive adapter. With it, we printed rubber darts for this vortex blaster. Or drive belts for this automatic card shuffler. Softer TPU also worked fine. The extruder clearly handles it better. I'm not saying this was impossible on cheaper printers, but here it was much easier. And of course, AMS expands the list of possible models even further. The catch is that with multicolor printing, the printer swapped filaments on every single layer. And besides taking way more time, there is something else too. Here! This is all the waste we collected during the print. In 3D printing slang, it's called poop. And yeah, even this stuff can be used for some interesting things. There are tons of different models online designed specially for it.
And there are also a lot of features.
First, the camera. It lets you monitor prints remotely and of course record time lapses. The quality isn't great, but it's still better than nothing. Second, the Bambu Lab app and everything around it. You honestly have no idea how convenient it is to have the slicer printer control and a massive model library with ready-made presets all in one place. There's even an AI model generator that turns your photo into a printable model in just a couple of minutes. Look how great Pixel's figurine turned out, I really like it. Overall, everything you could possibly need is here, especially if you're new to 3D printing. In the end, Bambu Lab basically took a very complex technical hobby and simplified it as much as possible. Calibration is automatic, waiting times are short, everything you need is always at hand. And most importantly, you're almost always confident your print will succeed. Well, to be certain, not always. We did have a few failures, but out of roughly 50 prints, only 2 went wrong. So, for capabilities a 9 out of 10, for features 7 points, and for overall impression an 8. And by now it's no secret, today's winner is obvious.
And the most important thing that this is one of those cases where the printer will stay with us. And it will keep working, we even prepare a special spot for it. And as for now, that's all. Bye!